Okay, so this is chapter 3, section 1. Now, as I go through chapter 3, section 1, it's all going to look like review. It's all stuff we've gone over in the previous slides. And then it's set up for 3.2. So basically, in 3.2, we're going to do derivatives of special cases. 3.1 just says, hey, where do we use this stuff? So as we go through, you'll not be surprised by anything you see in 3.1. So first of all, E. E shows up in a lot of formulas. It's an irrational number. If you want to see where it comes from, it's E is where you take the limit as n approaches infinity of 1 plus 1 over n raised to the n. You don't need to worry about all that. Just know that E equals 2.71728182845 and keeps going. But the bottom line is E is something that happens naturally. It's an irrational number that goes on forever. It's a symbol in your calculator that we've talked about, and it shows up. So where do we see E? We've seen E in compound interest when it's continually compounded. So here are some formulas that we've learned, okay? So when we do compound interest, we have simple interest. A is how much is in your account. P is principal. 1 plus R, R is the rate, times time. That will give you simple interest. But if your interest is compounded, then it's A is account, P, 1 plus R over M, R is rate, M is how many times a year, P is principal, M again is how many times per year, T is time. And then we have continuously compounded, account equals principal, E, there's that E symbol showing up, R is rate, T is time. So we've talked about all of these in previous slides. I'm just reminding you of them. And then the one I'm going to focus on is E, because E shows up in formulas like continuously compounding. We're going to take the derivative of an E. Or if we have stuff raised to a variable, how do we take the derivative of that? So 3.1 is just showing you, yeah, this stuff occurs in formulas. And then we'll take the derivative in 3.2. So if we look at continuous compound interest, A equals P times E raised to the RZ. A continuously compounded formula follows from the compounded formula with increasingly many compounding periods. So if we start with that formula P times 1 plus R over M raised to the MT, we take the limit as it goes forever. You notice it turns into compounded continuously. So again, don't have to worry too much about this. When we did talk about limit as it approaches infinity, going through your steps, you take this formula as it goes to infinity, continuous forever, and it becomes that formula. Don't worry about how it becomes one or the other, just that they're related. So if I tell you, suppose $1,000 is deposited to a savings account that pays 5% interest, calculate the amount in the account after 20 years, it depends on how we're calculating it. Are we doing it simple interest? Are we doing it compounded annually? And are we doing it compounded daily? And are we doing it compounded continuously? So to practice, I want you to take out your calculator. I want you to type in each one. Make sure you get 2,000. Type in the next one. Make sure you get 2,653.30. Type in the next one. Make sure you get 2,718.09. And type in the last one. Make sure you get 2,718.28. Number one, be familiar with the formula. Number two, find where the buttons are. Again, this is set up for when we take the derivative. Okay. Now again, it's important that you take out your calculator, type it in. You have to become familiar with your calculator, become familiar with what those numbers are. And all of this we'll be using in the next section. But again, we're just setting it up. Simple interest, compounded annually, compounded daily. If any one of these are not coming up, raise your hand. I'll come show you maybe the little difference in your calculator. Anybody else need any help? I'm going to type these all in. So I'm going to jump to my calculator. I'm going to type them in as well. So the first one would be 1,000 parentheses 1 plus 0.05 times 20, and you should get 2,000. The second one, 1,000 parentheses 1 plus 0.05 raised, it's above the division, 20. The compounded daily one, 1,000 parentheses 1 plus. Now, I always recommend putting anything in division in parentheses. It will work if you didn't. As I walk around, most of you didn't. But it will still work because division comes before addition. But as a good practice, you want to put parentheses around anything that's being divided. Raise. Now notice when I raise it, the 360 and the 20 all stay raised. But if yours has the little caret and it's lower, you need to put the 360 and the 20 in parentheses. And you know if you did it right if you get that answer. And then 1,000, we went over this before, the E button is by hitting second LN, E. And then again, make sure it's all raised. If yours doesn't have it raised, all of it needs to be in parentheses. So you get the 2718.28. Are we okay? So if becoming familiar with your calculator, we'll be doing the derivative, which will be the new part, in the next section. So if you have $1,000 vested at 6% interest compounded continuously, what will the account balance be after 5 years? How much interest is earned on this investment? So this one's compounded continuously. So we use A equals P times E raised to the RT. We plug in 0.06, and we get that. So step one, put that in your calculator. Make sure you get 1,349.86. And then we're going to practice something else. So type that in, make sure you get it, comfortable with the calculator. Again, we're going to be familiar with our calculator. So if we get 1,000 E raised to the 0.06 times 5, that's what you should get. Questions there? Now, I do want to practice something else. So take out your calculators. Let's go to y equals. Go to y equals. If you have any plots on, make sure you go up to it, hit enter. Let's make sure we have a clean calculator. None of the plots are highlighted, nothing in Y1, nothing in Y2, nothing in Y3, all the way down. Let's type in 1,000 E to the 0.06, and let's put an X instead of 5 years. Let's put an X instead of 5 years. X is how many years? X is how many years? So I go to Y1, I put the X. And let's say I want to use the table feature to plug in 5. So go to the table now and plug in 5 for 5 years and see if you get the same answer. So after you go to Y1, hit second graph to go to the table, and then plug in 5. Go to second graph, plug in 5, and you get the same answer. Remember, whenever you put an X, goes to Y1 and plugs in Y1. Did anybody not get that? Which means we have to set up your table. We did it before, but we can do it again. Did anybody not get that? Okay, remember second window, it should be Ask Auto. So when you go to the table, you can plug in anything you want. Okay, again, just practicing our calculator. So if a bank offered a 5-year certificate of deposit that earns 5.75% compounded continuously, if $1,000 invested in such a CD, graph the amount of the account as a function for a 5-year period. So here, that would be the graph, that would be the data. So let's get that in our calculator. So we have $1,000 compounding continuously at 5.75%. So we're going to go to our calculator, go to y equals. It's still $1,000, but instead of 0.06, it's 0.0575x. So it's $1,000 compounded continuously. That's why we're using the E at 0.0575x. I'm going to get those same numbers that the calculator got. So go to your table features, second graph, 0, 1, 2, 3, 4, 5. And that matches what the calculator got. Okay? Can anybody not get it that needs to see my y equals or need to see anything? And if I wanted to get the line, if I wanted to graph the line, I just have to put it in an appropriate window. So let's talk about that. If I wanted to graph this, what would be a good window for my x's? From what to what? Look at your x's. What would be a good window? 0 to probably 6, counting by ones. And then what would be good for my y's? You can start at 0. That's why they did. They kind of jumped up. And then go from 0 to what? 1,400 or 1,500, counting by hundreds, 200s, however you want. So again, let's go to our calculator. Go to window, 0 to 6, counting by ones. 0 to 1,500, maybe counting by hundreds. Hit graph. Why is the graph starting up here? That's 1,000, and you see it grow. Are we okay? Again, all stuff we did in the previous chapters, just reminding us a little bit of the E. Okay, getting comfortable with our calculator again. How long would it take an investment of $5,000 to grow to $8,000 if it was invested at 6% compounded continuously? So, I'm going to give you a minute. I want you to solve this. See if you remember the algebra to solve this. So 8,000 is what we're trying to reach. The formula is 5,000 e to the 0.06t. See if you remember the algebra to solve this. And if you're fast, see if you can do it in the calculator with a graph. If you're fast, see if you can do it in the calculator with a graph. See if you remember all the stuff we learned before. Remember, all that algebra stuff is going to come back to us. If you're fast, see if you can get in the calculator. Algebra review, and we're going to look at the calculator so we can figure that out. All right, let's see if you remember algebra. Algebra. If I wanted to solve for t, what would be step one? What? Divide by what? Divide by 5,000. Divide by 5,000. That would be the first step. So we have 8,000 divided by 5,000. That's 1.6 equals e to the 0.06 t. Stop there. Algebra. It's always going to be the issue in this class. You've got to remember your algebra. And this isn't algebra from college algebra. We did this in here. We reviewed this algebra. So we can't say, I don't remember college algebra. We did it here, right? Now, how do I get rid of the e? ln both sides. Because when you ln and e, they're like opposites of each other. That leaves us with ln of 1.6 equals 0.06 t. Then what? Gotta get t by itself. What's the next step? Divide by 0.06. Divide by 0.06. 0.06. T equals the ln of 1.6 over 0.06. Take out your calculator. Type that in. Take out your calculator. Type that in. So you have to know what the ln button is. ln of 1.6 divided by 0.06, 7.833. 7.833 what?
T.
It's t. What's t? Which is? Years. Eventually you'll get it, right? So how long will it take for my $5,000 to get up to $8,000? 7.83 years. Good. Did anybody get to do it in the calculator or in the graph? So we have 8,000 equals 5,000 e to the 0.06 t. It can be done in the calculator, but you have to understand a few things. Number one, we're going to put this in y1. We're going to put this in y2. Well, what's that going to do for us? If this is in y1, it's going to graph that exponential curve. This is going to graph 8,000. Where's my answer? Curve 8,000. Where's my answer? Where they intersect. But you're not going to see where they intersect unless you understand the window. Okay? So let's practice the calculator. Y equals y1 is 5,000 e to the 0.06x. y2 is 8,000. Now, before we move on, let's make sure we got that in there. What is my input? What is my input? What's my x's? What's x? Time in years. And what should we start with? 0. And we already know the answer. How many years is it going to take? 7.83. So my time is going to go from 0 to what? 10. Maybe 0 to 10. Counted by 2's, 1's, both good. What's my output? My output is money. And I'm starting at 5,000 and I'm going to what? 8,000. So what should I start with? 0 to 10,000. That's understanding the window. So when I go to window, 0 to how many years? Counting by 1s or 2s, your choice. My money, I'll start at 0. I'll go to 10,000, so I can see the 5,000 and I can see the 8,000. And your job is to find where the two intersect. And have we gone through all of this before? Yes. All coming back. The reason why we spend so much time in Appendix A in Chapter 1 is so now, I know what the buttons are, I know where everything is. Hit graph. How do you find where they both intersect?
Trace.
Second, trace, 5, enter, enter, enter. And you get the same answer, 7.833. Is this all coming back to you? Now, the last part of 3.1, I'm just going to kind of go over a little fast. It's just stuff we went over before. It talks about doubling. How long will it take for an investment to double if it's invested at 5.7% compounded continuously? Doubling means the account is 2p. Principal times 2, doubled. So if I just show you the math, the account needs to double. Doubling means 2 times p. 2p equals p times e to the 0.0575t. If I work that out, which I'll just show you, what ends up happening is, what's p divided by p, p divided by p? What happens to the p's? They go away, they become 1. So we're left with e to the 0.0575t equals 2. You tell me, what's the next algebra step? How do you get rid of the e? ln both sides. ln and the e go away. Then, what's next? I have 0.0575t equals ln of 2. What's the next step? Divide by 0.0575. Divide both sides by 0.0575. You get ln of 2 divided by 0.0575. And what do you get for the answer? 12.05 years. Now again, I'm not having you write it because we've already done one similar to it. But again, algebra, algebra, algebra. And they're about to show you a shortcut. When I double something, that's times 2, right? What happens if you triple something? Triple. Times 3. Quadruple something? Times 4. Interesting. When I double, it's the ln of 2 over 0.0575. What do you think would happen if I tripled? ln of 3 over 0.0575. What if I quadrupled? ln of 4. So it's kind of a pattern. I think it's not worth memorizing. You can just figure it out each time. But they're pointing out is, to find the doubling, your time equals ln of 2 over r. To triple, the time equals ln of 3 over r. And to quadruple, t equals ln of 4 over r. It's just a shortcut. But for me, we're focusing on using the calculator, knowing where the buttons are, graphing, table, algebra, algebra, algebra. Okay. Questions on 3?